Researchers recently handed OpenAI's Codex a live target and the matching firmware source code. They gave it no other instructions. Codex scanned the device's kernel memory, bypassed a block on the standard memory protocol by pivoting to the command line interface, and overwrote the process's user ID from 5001 to 0. With that sequence, the AI granted itself root access. An AI can now chain together a source code audit, discover an exploit, and execute a privilege escalation completely on its own. This significantly expands the attack surface for the billions of embedded devices currently running on legacy firmware. While AI is breaking into local devices, the companies building these models are busy locking their own doors. Anthropic recently launched their Claude Opus 4.7 model, alongside a 50% price increase and a new mandatory identity verification requirement for access. The community immediately benchmarked the new model and found measurable regressions. Opus 4.7 performs worse than its predecessor on tasks requiring sustained, multi-turn memory recall. Inside large tech companies, developers are now engaging in a practice called token maxing. Because enterprise teams are given artificial AI usage quotas, developers are deliberately burning tokens on useless queries simply to hit their performance metrics. Adding to the friction, new research shows that the numerical unpredictability in large language models is a baked-in, chaotic property of floating-point arithmetic inside transformer computation layers. Perfect determinism is mathematically impossible with this architecture. Cloud AI is currently characterized by mandatory ID checks, bloated enterprise costs, and a processing architecture that produces unpredictable results at scale. When Anthropic announced its identity requirements, a massive flight toward local, open-source AI models erupted across developer forums. Alibaba's QN team then released a 35 billion parameter model using a mixture of experts architecture. It is built to activate only 3 billion parameters at any given time. That low active parameter count means this highly capable model runs perfectly on a single consumer graphics card, entirely severing the need for a corporate data center. In community testing, this localized QN model actually beat the much larger cloud-based Claude Opus 4.7 in an agentic coding benchmark that required drawing a complex vector graphic of a pelican riding a bicycle. Open-source models are highly optimized engines that are outperforming proprietary models on targeted, multi-step tasks, doing it at a fraction of the compute cost. Google DeepMind recently released the Gemma 4 family. The architecture now includes native aspect ratio understanding, processing landscape and portrait images as they actually are, instead of squishing them into squares. Developers immediately managed to run the 2 billion parameter version of Gemma 4 completely offline on a first-generation Nintendo Switch from 2017. Google also released Gemma 4 under an Apache 2.0 license. This removes previous commercial use restrictions, allowing developers to fine-tune and build derivative models without corporate oversight. The hardware floor for running capable, creative generation has dropped to consumer electronics that are nearly a decade old. AI reasoning models operate 10 to 50 times faster than humans, but they are currently colliding with software infrastructure built around a human reading speed of about 3 bits per second. GitHub recently allowed repositories to disable pull requests entirely. The classic line-by-line human code review is obsolete because it is too slow for autonomous coding agents. Instead of just generating isolated lines of code, these agents are now sharing high-level debugging strategies and validation routines across entirely different problem domains using persistent memory pools. As the execution layer becomes fully automated, the value of the human developer moves upstream. The job is shifting from writing the code to encoding taste, judgment, and high-level strategy. This autonomous efficiency is scaling across other domains. At the AAA AI 26 conference, an AI system reviewed nearly 23,000 scientific paper submissions in less than 24 hours. When surveyed, the conference participants preferred the AI-generated peer reviews over the human ones, specifically citing higher technical accuracy and better research suggestions. A study of nearly 1,000 students revealed what researchers called the cognitive offloading paradox. Students who used AI occasionally actually performed worse because of the coordination overhead. But students who strategically delegated entire task categories to AI saw massive improvements, freeing up their cognitive capacity for higher-order reasoning. The industry faces a stark divergence. You can rent access to massive, unpredictable cloud models gated behind an identity check, or you can embrace complete cognitive delegation using highly efficient open models running locally on hardware you control.